Hello buddies. Welcome to the Silver Mind. Can you find the total resistance of this set of infinite resistors? I recommend you to pause the video and try to get the answer. Okay, now we see the proof. Before the proof, we should learn that there are two methods of connecting resistors. First one is series connection. This figure shows a combination of resistors in series connection. Here, to get the total resistance of these resistors, we should add the resistance of each resistor. Then in here, total resistance is equal to R plus 2R plus R, then total resistance of these three resistors is 4R. Second method is parallel connection. This figure shows a combination of resistors in parallel. We can calculate the reciprocal value of total resistance by adding the reciprocal values of each resistor. Then in here, 1 upon total resistance is equal to 1 upon R plus 1 upon R plus 1 upon R, then reciprocal of total resistance is 3 upon R, therefore total resistance is R upon 3. Now we can start the calculation. Here, we assume that the resistance of infinite set of resistors as R. I want to ask you something. Do you have seen the ocean? Can you guess the number of water drops in the ocean? Is it countable? No. What happens if we remove one water drop from the ocean? Is there any countable change in the amount of water? No. There is no change. Similarly in here, if we remove one branch from this set of resistors, still its resistance is R. Therefore we can redraw this circuit as below. First, by drawing the first branch and replace all other resistors as R. Now we can do the calculations using this figure. Here, 2 ohm resistor and R is in parallel connection. Let the total resistance of these two resistors is R dash. Then, 1 upon R dash is equal to 1 upon 2 plus 1 upon R. Now, 1 upon R dash equals to 2 plus R divided by 2R. Then we can have finally R dash equal to 2R divided by 2 plus R. Now we have here the total resistance of 2 ohm and R as R dash. Then we can substitute a resistor with the resistance of R dash instead of both 2 ohm and R resistors. Here, R dash is equal to 2R divided by 2 plus R. Now in this figure, 1 ohm resistor and R dash resistor is in series connection. Therefore, we can find their total resistance by adding their resistances. Then, total resistance equals to R dash plus 1. Now, substitute R dash with its value in term of R. Then we have total resistance equal to this. And here is the point. At the beginning we decide that the total resistance of this set of infinite number of resistors as R. Therefore, total resistance also equal to R. Then, we can write R equals 3R plus 2 divided by 2 plus R. Then, solve this equation like this, and finally we can have a quadratic equation as R square minus R minus 2 equals 0. To get the answers, now we have to solve this quadratic equation. Here, R square minus R minus 2 equals 0. Then we can write, by factorizing, R minus 2 into R plus 1 equals 0. Then this to be true, R minus 2 should be equal to 0, or R plus 1 should be equal to 0. Then finally we can have that R equals 2, or R equals negative 1. Here, resistance should not be a negative value. Therefore, R equals negative 1 cannot take as an answer. Since that, the total resistance of this infinite long resistance combination is 2 ohm. If you learned something from us, please subscribe and click the bell icon for more videos. And comment your questions in the comments section. Thank you for watching us.